Good morning, dear students. Today we're having the 16th practical lesson. It is about a system of differential equations. Uh, let's start solving these systems. And so let me first of all write it down, this system. So the second derivative by x equals y, and the second derivative of y uh, by t equals x. And we will solve this system with using elimination method. So how we will use this method? We will transform this system into the single equation, and we will eliminate one of derivatives. So actually it doesn't matter which to eliminate. Let us eliminate derivative of y. So how we will do it? So we will differentiate the first equation twice. Okay. So differentiating it twice. What I will receive? So the fourth derivative of x by dt by t 4 times equals, so it will be the second derivative of y. So I will receive the following equation. So substituting here the second derivative of y, and I will receive the following equation. Now let me move let me move x to the left part, and actually we will see that this is a linear homogeneous equation with constant coefficients. So let's solve it. So what do we have? K in power of 4 minus 1 equals 0. Let's factorize it. So k squared plus 1 by k plus 1 by k minus 1 equals 0. So we have the following roots. K1, 2, it is a pair of complex conjugate roots. And k 3, 4 equals plus minus 1. So two real roots. So x will be equal c1 cosine of t plus c2 sine of t plus c3 e in power of x what's going on, and minus and plus c2 plus c4 e in power of minus x. And how to find y? We can find y from this equation. So y equals the second derivative of x. So let's differentiate now x twice. So minus c1 sine of t plus c2 cosine of t plus c3 e in power of x minus c4 e in power of minus x, and finding the second derivative. So minus C1 cosine of t minus C2 sine of t plus C3 e in power of x and plus C4 e in power of minus x. And actually it equals y. So the final answer will be the following. So the general solution of the system. So x equals this expression and y equals this. Any questions about this exercise? Okay, if no questions, let's move next. Let's solve 1b. So one more example for elimination method. Yeah, by the way, this system had the fourth order because, yeah, sum of the highest orders of derivatives equals 4. So second derivative, and if we sum the order, we will receive 4. And here we have the second order of the system because sum of derivatives order is 2. Let me remind you such theoretical information. So dx by dt equals x plus 2y. Dy by dt equals 4x plus 3y. So let's eliminate dy by dt. So doing actually the same stuff, so we will differentiate the first equation. So d2x by dt twice equals dx by dt and plus 2 dy by dt. Okay, found it. So how, and now let's substitute, yeah, let's move here let's move x into another side. So minus dx by dt. Yeah, and by the way, yeah, dy by dt will be equal, so this expression divided by 2. Okay, done. So now let's substitute it into this equation. So dy by dt equals this expression and equals 4x plus 3. Yeah, and how to express y? Actually, y equals so from this equation, y equals 1 over 2 dx by dt minus x dt, yeah, 1 over 2 dx by dt minus x. So plus 3 over 2 and this expression. So now no y in this equation, only x. So then what are we doing next? The next is, so we will expand brackets. Yeah, but maybe first of all, let us multiply by 2 this equation. So I will have here this expression. Here will be 8 and here will be 3. And now expand in brackets. And minus 3x. Continue. Yeah, now let's move x to the to the left. Actually, we will receive the homogeneous equation. So here will be minus 4 dx by dt. Here will be 5x and here minus 5x. So equals 0. And let me check if everything here is correctly. Yeah, so minus 4 minus 5. So now solving this homogeneous equation, writing down characteristic equation, k squared minus 4k minus 5 equals 0. Then x1 or k1 equals minus 1 and k2 equals 5. So x equals c1 e in power of minus x plus c2 e in power of 5x. Now finding y. So y will be found from this equation. Let's first of all differentiate x. X equals minus c1 e in power of minus x plus 5c2 e in power of 5x. So y will be equal 1 over 2, substituting these expressions. So this expression minus this. So 1 over 2 minus, okay, what I will have here. So minus 2c1 x, minus 2c1 e in power of minus x1, and plus 4 c2 e in power of 5x. And finally, it will be, so here will be minus 1 and here 2. So the final answer will be the following. So x equals c1 e in power of minus x plus c2 e in power of 5x, and y equals minus c1 e in power of x plus 2 c2 e in power of 5x. So this is the final solution. Any questions about this exercise? Okay, no questions. So now let's move to the second exercise, 2a. So now we will find the general solution of a system of differential equations using Euler's method. So writing down the first equation. Oh, by the way, we have only 2 equations, not 3. So dx by dt equals x plus 2y. By the way, if I'm not mistaken, we had we have the same system of equations, so I didn't have to raise it, but nevertheless. So dy by dt equals 4x plus 3y. So how we will use Euler's method? First of all, let's write down the matrix of the system. So it will be the following. Matrix of the system. So we will write coefficients before coefficients for these functions. So the first row will be 1, 2, and the second row 4, 3. Then we will find the we'll find eigenvalues and eigenvectors. So okay, let me copy and paste it. And here will be minus a lambda, 1 minus lambda, and 3 minus lambda equals 0. What's going on? So everything moved to the middle. So equals 0. Then so 1 minus lambda by 3 minus lambda minus 8 equals 0. Now expand in brackets. So 3 and then minus 4 lambda plus lambda square minus 8 equals 0. Then so okay, let me rewrite it. So lambda square minus 4 lambda minus 5 equals 0. So actually we have the same characteristic equation that was in the first case. In the previous exercise, and that's correct that they match because we have the same systems. So lambda 1 equals no, minus 1, and okay, let me write it down here on the next row. So lambda 1 equals minus 1, and lambda 2 equals 5. So what about lambda 1? Let's solve eigenvector. So we will have the following system. So here will be 2, here will be 4. So A minus lambda E matrix, if as you remember. So it will be reduced to the following system. So we will receive that x1 equals minus x2. So then x that corresponds lambda 1 equals so what we use, so 1 minus 1. So we will substitute these values. So x2 will be equal. Okay, let me check here how I use in my notes. Yeah, 1 minus 1. Yeah, and here I use y. And for lambda equals 5. So I will receive here minus stop. No, minus 4, and here minus 1. Minus 2. Then we'll receive so 2 minus 1 0 0. So x2 will be equal to x1. So then y that corresponds lambda, so eigenvector that corresponds lambda 2 equals 1 2. Yeah, so actually I can use constant c, for example. Yeah, so c and 2c, and I can assign c equals 1. Yeah, so actually according to this notes. Then how to write down the solution of the system? So it will be the following. So let us write it down like a vector function. So it will be written in the following way. So C1 by y that corresponds lambda1 by e in power of minus x plus analogical. So C2 by multiplied by lambda vector 2 and e in power of 5x. So where we take minus x and 5x, so from this characteristic equation. So now let's write down it in details. So, okay, let me just do like this. So substituting y here and y here. Then receiving the following matrix. C1 e in power of minus x. Oh, it will be just a vector, one vector column. So C1 e in power of minus x plus C2 e in power of minus e in power of 5x. And here minus C1 e in power of minus x plus 2C2 e in power of 5x. So this is the solution of the system. And how we will, yeah, so, and as we written before in another form, so this is the solution, and it matches the solution that we received in exercise 1. So it means that it is solved correctly. Any questions about this exercise?
Sorry, I have a question.
Yeah.
So, in Euler's method, in this like the result matrix, so the first row is like the x value, and the second row is y,
Yeah,
right?
yeah, actually that's not a matrix, that's a vector.
Oh, sorry,
Vector,
vector.
yeah. So the first
Okay.
coordinate is x and the second is y.
Okay.
So
Yeah,
I
yeah.
just multiplied it by C1. Yeah, I can write it in details, for example. So yeah, how it will be. So here will be C1, here minus C1. Oh, what's going wrong? So the first and the second, analogically. So just reminded you actions with the matrices, and then received the following stuff. Yeah, even not matrices but vectors. So yeah, any more
Okay.
questions? Is it clear? So have I answered your question?
Yeah, it is
Mhm.
clear now.
Okay, more questions?
You can continue.
Maybe anybody else has questions? Okay, if no questions, let's continue. Let's solve the next equation. So we have 3 interesting cases in this exercise. So dx by dt equals x plus y, and dy by dt equals minus 2x plus 3y. So again, writing down the matrix, finding eigenvalues and eigenvectors. So matrix A will be equal, so the following coefficients: 1, 1, minus 2 and 3. Now writing down the characteristic equation. One minus lambda and 3 minus lambda, and it equals 0. Actually, we will not solve in details this equation. I will just look into my notes, so we will skip this process. And what we will receive. So lambda 1, 2 will be a pair of complex conjugate complex conjugate roots. So then we will do the following stuff. Yeah, and actually for finding these eigenvectors, so again, I will not solve the whole system. I will just, yeah, so we'll just skip all details. So the first eigenvector will be the following. So just to save our time with the calculations and with the calculations of complex roots. So 1 and 1 plus I. So this is the eigenvector. Actually, yeah, I can substitute, so C and I substitute just 1. So, actually we have, yeah, it is enough to find only one solution. So X lambda will be the following. So X lambda from T, so it equals, so this stuff multiplied by E in power over 2 plus I and in power of T. So now we will write it, so we will do some calculations. So we will expand everything. So here I have 2e, and so e in power of 2I, and multiplied by e in power over 2t. So then what actually will be equal e in power of 2I? So e, stop. E, so I in power of t. So I in power of t, actually it will be equal the following. So cosine of t plus I sine of t. Then I will move cosine and sine into the under this vector. So moving it here, cosine of t plus I sine of t, and here what I will have, so cosine of t plus I sine of t, then plus I cosine of t minus sine of t. And everything multiplied by e in power of t. Then let's regroup real and imaginary part. Let's separate them. So what I will receive? Yeah, so actually moving I here out of brackets. And then So here just cosine of t, and here cosine of t minus sine of t. And here will be, okay, let me move I here. So sine of t, and here cosine of t plus sine of t. So found it. So we can see that here is a real part and imaginary part. And actually, how we will find x now? So x from t, yeah. So the first solution will be real part, and the second imaginary part. Now, how to explain it better? Yeah, so x, so the first x, x that corresponds lambda 1 from t, it is so corresponds a real part, and the second x is imaginary part. So x with index lambda 1 from t equals a real part of this expression. So it equals this stuff. And the second x that corresponds the second lambda. So it equals imaginary part of this x. And the final answer will be sum of this x. So C1 x lambda 1 plus C2 x lambda 2. So now writing everything in details. So performing multiplication and adding. So here will be C1 cosine of t. Here C1 cosine of t minus C1 sine of t. E in power of t will be still out of brackets. So what we will receive? So C1 cosine of t plus C2 sine of t. Then here, so grouping around trigonometric functions. So C1 cosine of t. No, stop. C1 plus C2 cosine of t. And plus, so minus C1 plus C2 sine of t. And here will be in power of 2t. So this is the solution. How write it in another form? So x will be equal this expression multiplied by e in power over 2t. And the expression for y is the following. So this part will be multiplied by e in power of 2t. So any questions about this exercise? Okay, I guess that no questions. So moving next. Solving 2C. 2C. So another interesting case. So dx by dt equals 2x minus y. Dy by dt equals 4x plus 6y. So again, writing down the matrix. So A equals 2 minus 1, 4, 6. Writing down the characteristic equation, and which we will not solve now step by step. So analogically to the previous exercise. So yeah, so we have a pair of multiple roots. So multiplicity of the root is 2. So we have so lambda 1 and 2 equals 4. So yeah, and it is also real. So we will find the solution in the following form. So it will be so x and y will be will look like a sum of products of polynomial and multiplied by e in power of 40. So let me write down how it will look like. So alpha 1 plus uh, beta 1 t, and here will be alpha 2 plus beta 2 and multiplied by e in power of 4t. And here we will just, so linear functions multiplied by exponent. So we will use it, so we will use method of undefined coefficients. Actually how to define, how to define these coefficients. So we will differentiate these expressions that we have for functions and substitute into the initial system. And from it we will find alpha and beta coefficients. So differentiating x, so it will be equal for alpha plus for beta, for alpha 1 plus for beta 1 t and plus beta 1. Then y prime, actually it will be the same, but another indices on over alpha and beta. So yeah, and forgot to multiply by e in power of t. So now everything in power of 40. So everything is correct now. So now substituting it into the initial system. So substituting first of all derivatives. And then substituting functions. So substituting x, substituting y. Now let's cancel e in power of 40. We don't really need it. Let's check with the system. So for beta 1t, yeah, plus for alpha 1 plus beta 1 equals, so here 2, here minus 1, then for alpha 2 plus 4 beta uh, 2 plus, plus 4 beta 2t plus beta 2. Now we will not solve this system in details, and we will just write down the final solution of this system. So some of variables and alpha 1 and beta 1 are free, and beta 2 alpha 1 alpha 2 beta 2 are basis variables. So alpha 1 equals C1, beta 1 equals C2. Then, yeah, as we can see here from my notes, so beta 2 equals minus 2C2, and alpha 2 equals minus 2C1 plus minus C2. So found these undefined coefficients. So then we will write down the solution. So we will substitute them into, yeah, we will substitute them here. So alpha 1, so C1 plus C2 T, and what here, so substituting these constants and minus 2C2. So this is the final answer of the system. Any questions about this exercise? Okay, if no questions, let's have a break for 5 minutes, and after that we will continue solving a system of differential equations using other methods. Let's continue. Now we're having the next exercise. So before we solved only homogeneous systems of equations, and now it will be inhomogeneous system. Why? Because we have inclusion of t, so three members, so not only functions that we need to find. So here plus t and here plus 1. So let's start solving. So the first method that we have to apply is elimination method. So uh, the method that you already know, and the second method of selecting the form of the partial solution by the form of the right hand side. So, but first of all, method that you already know. So let's exclude y prime. So differentiating the first equation. So x prime twice plus 6x prime plus y prime and plus 1. Then what do we have? That y equals okay, so we will eliminating y. So y equals x prime minus 6x and minus t. And y prime equals so x prime twice minus x minus 6x prime and minus 1. Now, substituting these expressions into the second equation. So substituting y prime. So equal, then it equals 5x plus 2 expression for y and plus 1. Now let's expand brackets then. So expand brackets and simplify this equation. So 2x prime minus 12x minus 2t plus 1. Then moving moving x to the left side. So here will what I have, so 2x prime, so here minus 8x and here minus 7, so plus 7x. And here will be 2t plus 2. Let me check with so yeah, minus 2t. Yeah, I was minus here, so minus 2t plus 2. So we received the linear inhomogeneous equation, but first of all, yeah, so we will find it as we did before, so the sum of solution of homogeneous equation plus partial solution. So now solving homogeneous equation. So k square minus 8k plus 7 equals 0. Then by Viet theorem, we will find that k1 equals 1 and k2 equals 7. So x0 will be equal c1 e in power of x plus c2 e in power of 7x. Now differentiating Yeah. What about partial solutions? So x partial. So according to the right side, so uh, this is a polynomial and it is a special function with control number 1. So x uh, partial will be found as polynomial of the first power. So it says a linear function. So let's differentiate and substitute into this inhomogeneous equation. So x prime equals a, and x prime twice equals uh, 0. So substituting. So minus 8, so minus 8a plus 7at plus b equals minus 2t plus 2. So I will not solve it now. Uh, I will not solve this equation. I will just write down the answer. So the undefined coefficients are following. So a equals minus 2 over 7. Uh, b equals minus 2 over 49. So then x partial equals minus 2 over 7a minus 2 over 7t minus 2 over 49. And x will be equal the following. So uh, so homogeneous plus partial. Then how we find y? We will find it from this expression. So let's differentiate x. So okay, let me just write it like this. So C1 here will be 7C2, and here minus 2 over 7. And y equals, so let me rewrite this expression. So it equals the following stuff. So this, so x prime and minus 6x minus t. And after we expand all brackets, so we will receive the following expression. So minus 5c1 in power of t. X everywhere, sorry, t here, so it was a mistake. So just so as I'm used to write everyone in power of x, but t here. So and nobody told me about it. Okay. So moving next. Plus C2 e in power of 70 plus 5 over 7 t minus 2 over 49. So the final answer will be the following. So x equals this expression, and for y expression is the following. So found it. Any questions about this exercise? Okay, if no questions, solving with another method. Okay, I will not erase the system, so 3b, and with finding the partial solution. Oh, how? Okay. Oh, let me check. Yeah, so selecting of the form of the partial solution by the form of the right hand side. So, yeah, let us write down first of all the matrix of the equation and uh, uh, the column of three members. So, matrix of the equation has coefficients 6, 1, 5, 2. And the vector over three members, so over right hand side is t and t1. And first of all, we need to find the generic solution over the homogeneous system. So writing down the homogeneous system, yeah, actually now we don't need it. So let me erase this three members, and we will use it. We will solve it with using Euler method. Two minus lambda equals 0. So actually, according to this equation, lambda 1 and 2 must be equal 1 and 7. And yeah, so that's correct. Then, so yeah, finding the eigenvalues and eigenvectors. So for lambda 1, so the matrix will be the following. So 5, 1. So the second equation will be eliminated. So the first, so y1 will be, so y lambda 1 equals 1 minus 5. Then for lambda 2, so what I have, so minus 1, and here minus 5. So the answer will be the following. Oh, y2. Okay, I can write down 2, 2, but it's better to write down 1, 1. So it's more convenient to substitute c equal to 1. So found it. Then the solution of homogeneous system is the following. So C1 multiplied by this expression, e in power of t, plus C2 multiplied by vector 1, 1, e in power over 70. And what about the partial solution? So actually analogical to analogical to single differential equations. So we look at the right part. Well, we actually choose the here, so the highest degree of polynomials. So in this case, the highest degree is 1. Control numbers are 0, so no exponents. So we find it in the following form. So again, we will use method of undefined coefficients. So at plus b, just okay, it will be a single vector. So at plus b and ct plus d. So how to find coefficients? We will substitute them into the initial system. So x prime will be equal a, y prime will be equal c. So now substituting into the initial system. So a here, c here, so 6x, then 5x. Stop. Plus y, not minus. Okay, plus. And here plus 2. So this. Let's check the system if it's correct. Again, we will not spend the time for finding coefficients. So yeah, a equals 6 at plus b plus ct plus t plus d plus t. Okay, c equals 5 at plus b plus 2 ct plus d plus 1. So everything matches. And now let's just write down the coefficients. So a equals minus 2 over 7, b equals minus 2 over 49, c equals 5 over 7, and d equals minus 2 over 49. And now let's write down the solution. So it will partial solution will be the following. So minus 2 over 7t minus 2 over 49. Then 5 over 7t minus 2 over 49. And the general solution will be sum over the solution of homogeneous system plus partial solution. So and plus this. So actually, yeah, let's rewrite it in more accurate way. So here will be C1 e in power of t plus C2 e in power over 7t. And here minus 5C1 e in power of t plus C2 e in power of 7t. So that's the final equation. And again, I can write down like this. X equals this expression, and for y, this expression. Any questions about this exercise? Yeah, and as we see, so answers match, so everything is correct. So any questions? Okay, if no questions, let's move to the exercise 4. So now we will have to solve the Cauchy problem, and we will use method of variation of arbitrary constants that you already know, and how it will be used for the system. So again, we will find the solution as sum of homogeneous of the solution of homogeneous system and a partial solution. So dy1 by dt equals 4y 1 minus 4y2 plus 4t plus 1. Then dy 2 by dt equals y1 minus 2y2 plus t. So solving, and by the way, writing down the initial conditions. So the second order of the system, so two initial conditions. So y1 from 0 equals 1 and y2 from 0 equals 2. So let's solve first of all homogeneous system with using Euler method. 4 minus 5, 1 and minus 2, 4 minus lambda and minus 2 minus lambda. So equals 0. So let's write down the solution of this characteristic equation. So lambda 1 equals minus 1 and lambda 2 equals 3. So let's find eigenvalues and eigenvectors. So for lambda 1, we will have okay, so 5 minus 5 and 1 minus 1. So the eigenvector will be equal. For this vector, so it equals 1, 1. Let's choose this value. And what about lambda 2 equals 3? So the following matrix. So 1 minus 5 and 1 minus 5. And the eigenvector for it will be equal 5, 1. So the solution of homogeneous system is the following. C1 multiplied by 1, 1 e in power of minus t and plus c plus c2 multiplied by 5, 1 e in power over 3t. Then how we will find y1 and y2. So y1, okay. By the way, yeah. So we found the solution of a homogeneous system. So now we will assign C1. So consider C1 and C2 as functions that depend on t, and we will find these functions. So y1 equals C C1 from t e in power of minus t plus 5c2 from t by e in power of 3t. Then y2 equals c1 from t e in power of minus t plus c2 from t e in power of 3t. Now differentiating this y1 and y2, so actually we will substitute them into the initial system. So let me paste it here, and now we will differentiate y. So y1 prime. So y1 prime equals c1 prime by e in power over minus t minus c 1 e in power of minus t plus 5c plus c2 prime e in power over 3t and plus 3c 3c2 e in power over 3t. And what about the derivative of the second function? So this part is analogical, and here, okay, plus c2, and here will be 3c2. Stop. Here must be 15 because multiplying by 5, and I lost it. It's not a good idea to lose them. Okay, now substituting. So substituting this derivative and this derivative. Now substituting y1 and y2. So this is the system from which we will find C1 prime and C2 prime. First of all, let us check that C1 and C2 will eliminate, so they must be eliminated. So expanding brackets, so 5 here, 20 minus 5 minus 5 minus 2 minus 2. So let's check if C1 and C2 are how to say that they are eliminated. So 4, and here, so minus 5. So if I move C1 here, it will be eliminated. So C1 eliminated in the first equation. So you always must verify it. So if C1 and C2 won't be, if C1 and C2 are not eliminated, it means that you made a mistake. So here I have 15, here 15 as well. So 15 C2. So eliminating. So the first equation is correct. What about the second equation? So C1 minus C1, and here minus C1 as well. So eliminating 3C2 in on the left and 3C2 on the right. Eliminating. So received the following system. Okay, now I will not spend time for finding these derivatives of C. I will just find the solution. So C1 prime will be equal. Okay, let me write down it here. Let me write it here. So C1 prime equals 1 over 4 t minus 1 e in power of t, and C2 will be equal 1 over 4 3t plus 1 e in power over minus 3t. Then after the integration, I will receive that C1 will be equal 1 over 4 t minus 2 e in power of t, and C2 will be equal minus 1 over 12 3t plus 2 e in power of minus 3t. So let's write down the partial solution, how it will look like. So let me copy and paste it. So instead of C1, substitute in this expression, and this expression instead of C2. So minus 5 over 12. Here minus 1 over 12. So what will be simplified here? So I will eliminate e in power of, so I will eliminate exponents for both parts. So the general solution will be the following. So, okay, this is partial. So both of these solutions are partial, by the way. So the general solution, y 1 equals okay, this expression plus this, and y2 equals this expression plus this. And by the way, we also have to so we don't we have not we have to not only find the general solution, we have to find the partial solution to solve the Cauchy problem. So with using these initial conditions, so first of all substitute in y1 and y2. So here I have C1 plus 5C2. So 1 over 2 here, minus 1 over 2. and minus 5/6. Minus 1/2 here, and minus 1/6. Here Z is so C1 and C2. Let me check with my notes. So yeah, it matches. So system match. So I will just write down the solution of this system of algebraic linear algebraic equations. So C1 equals 11/4, and C2 equals minus 1/12. So writing down the solution. So just substituting everything instead of C. Yeah, minus 1/12 and minus 5/12. So this is the final solution. Any questions about this exercise? Okay, no questions. And now having the last exercise, so we will just look it through. So we have to find a partial solution to the system. So the first system, so x1 prime equals minus x2 plus t in power of 2, and x2 prime equals x1 plus e in power of t. So we have for the first equation, free member is a polynomial function, and for the second equation, free member is a exponential function. So we need to solve the characteristic equation for this system. So for homogeneous system, and so it is the following. So the roots of this equation are plus minus I. And control numbers of f1 and f2, they are not roots of the characteristic equation. So the solution will be the following. So partial solution will be analogical to functions f1 and f2, but actually this so it will be sum of these functions, but with undefined coefficients. So for x1, it will be polynomial of so sum of polynomial of the second order with undefined coefficients and undefined coefficients before the exponent, and analogically to x2. So with using method of undefined coefficients, received the system of 8 linear equations, so with 8 unknowns, but this system is quite this system is quite easy to solve. So found these undefined coefficients, and then just substituted them into the expression of a partial solution. Any questions about this exercise? About the whole lesson, about previous lessons, maybe you have questions. Okay. If no questions, let's finish. Have a nice day, stay safe, and thank you for your attention. Goodbye.
Thank you for this lesson. Take care.